Shall we? So we'll concentrate only on reflection today. Is everyone there online? All right. वाह, आन्या बड़ी हंस रही। आन्या, कुछ गड़बड़ हो गया क्या इसमें? कोई आपको आपका बचपन के चेहरे के जैसा एक जैसा लगा क्या? हाँ, चश्मा पहना दो तो आप ही के जैसे ही, आप ही के जैसा है। देखो ऐसा, बड़ी हंस रही हैं आप, इसलिए मैंने सोचा। ठीक है। So how I have done this is actually, as I said, that we will have the NCERT revisions only right now. So though you will get it, don't worry about the resolutions and all. When you get it in PDF, everything will be okay. So what I have done, this is every portion of NCERT I have pasted here. This is the NCERT portion. What is the takeaway notes from here? ताकि आपको और easy लगना शुरू हो जाए ये, ठीक है ना? So this is the first page and first portion. कुछ activity है तो उसको cut किया है. So this is the first portion, and we'll discuss each and every point that makes relevance from the NCERT perspective. If you want to know more, then the detailed videos are always there. So the first thing, 1 mark questions. Light is a form of energy and is needed to see things around us. That is nothing there. Okay, we see things from which light comes reflected. Now this is grade 8 stuff. In order for us to see something, light from a, suppose I want to see this fellow Atish. So light from a source has to come and hit Atish, and then that light ray has to come and hit back on my eyes. Rays, beam, all these are imaginary just to facilitate the geometry of ray optics. Otherwise, there's nothing called a ray. Ray is there for us to understand how images are formed, how images, you know, so there's the size of image, what is the orientation of image. For that we need to have some sort of a geometry. To facilitate that geometry, we have the concept of rays, we have the concept of beam. Beam is a collection of rays, and the object can send the reflected ray directly to me, or he can even reflect it to somewhere else, and from there also it can come to me. End of the day, the geometry that has to be satisfied is light from a source has to fall on an object, and from that object, either directly or by multiple other reflection, it has come back on my eyes, then only I'm able to see. Is this fine? Now this is grade hero stuff. Light travels in a straight line, which is known as rectilinear propagation of light. When you learn about light, now the part that you are learning in this chapter, let us again understand, you are learning only the ray optics part. So थोड़ा सा समझ लेते हैं, ये आपको 12th में help करेगा. Light is only a small portion of the electromagnetic spectrum of the sun. You know that, right? The electromagnetic spectrum of the sun is an electromagnetic radiation in which we see a very small portion, VIBGYOR, which is light. All you are studying in grade 10 is actually known as ray optics. Now, what is ray optics? Ray optics studies that branch of light where the objects that you are dealing, their sizes are much, much bigger than the wavelength of visible light. The wavelength of visible light is 4 into 400 to 700 nanometers. इनसे ऑब्जेक्ट्स काफी बड़े बड़े हैं, जैसे मान लो एक ट्री हो गया, एक ह्यूमन बीइंग हो गया, एक गाड़ी हो गया. इन सब चीजों को we study under ray optics. There is another branch which is known as wave optics. When we study wave optics in grade 12, we will be studying objects and their behavior, light's behavior to those objects, and those objects will be so small that their size is comparable to the wavelength. At that time, you will find that the same light which travels in a straight line, from kiddo days you have heard, does not travel in a straight line. Light will start to bend, like phenomena like diffraction and other. So light, initially, when quantum of mechanics and all were not there, and we are talking about Newtonian era, at that time light was studied as light is a particle theory. Light travels in a straight line. Then somebody started that diffraction and other things could not be explained. So light is a wave. Today, the model that we follow is light is dual nature. There are particles which follow the wave method also. Okay? So light is an electromagnetic radiation. Light is also a particle. So what is the nature of light? Light's nature is dual nature. Diffraction, there has been a mention about here. So what is diffraction? Just for your knowledge, nothing more, nobody will ask you, is a phenomenon where light waves bend around the edges of obstacles or openings. Remember, these obstacles or openings cannot be the ones like my table or the door. These have to be so small that their size should be comparable to the wavelength of light. Then only you will see diffraction happening. Light will actually bend. So in grade 12 textbook, they write a very nice thing in NCERT. They say, up till grade 8, light was young, so light was going straight. Now light has aged, so light also starts to bend. So light actually bends around the corners, but that is a part of wave optics. So You have understood the concept of ray and wave optics. This is nothing to do with your syllabus, just for your understanding purpose. Ray optics, everything that you deal with, rays. In short, the phenomenon of light and its reflection when the objects are much, much bigger as compared to the wavelength of light. Wave theory, light is an electromagnetic wave which is non-mechanical in nature. Non-mechanical, what are mechanical waves? Mechanical waves are those waves which need a medium for propagation. Light does not need, light vacuum mein bhi ja sakta hai. That's the reason we are getting sunlight right from the sun to us and does not need a medium. Particle theory, light is composed of particles which travel in a straight line at high speed, photons bolte hain. And the theory that we say is light follows dual nature, exhibits properties of both wave particles depending on the nature it is in. So actually light is composed of particles and these particles will follow a wave nature. Some data you should know. Speed of light is 3 lakh kilometers, 3 into 10 to the power 8 meters per second, 3 lakh kilometers, and wavelength is 400 to 700 nanometers, or 4 into 10 to the power 7 to 8 into 10 to the power 7. Is this much understood? यहाँ से तो कोई सवाल आने के chances नहीं है. Children, are you able to see this thing in online? This part, can you see online? Okay, this part is not for your importance. This is to show that for which part we are studying what content. I'll go this side. I think it's better now. Right, Akshat, all okay? Yes. Today Ashka is down. So almost everybody had fever. Whoever did not have fever, please be very careful. Next. This is our second section. Terminologies for reflection. We may break early also today. A ray of light which falls on a mirror surface is known as the incident ray. Kiddo stuffs. Point at which the incident ray falls on the mirror surface is called the point of incidence. The ray of light which is sent back by the mirror or any reflective surface is known as the reflected ray. Normal is a line. Normal. Whenever you hear the word normal, like you'll be hearing the word a lot in when we study tangents to a circle. So radius is always normal to a tangent. Normal means a 90-degree orientation. The normal is a line at right angle to the mirror surface at the point of incidence. So where the incident ray goes and impinges upon, that is called the point of incidence. Wahan pe jo 90-degree pe line banega, that is known as the normal. Angle of incidence is always the angle. Many people, means very few people have done mistakes here also. Angle of incidence is always the angle between the incident ray and the normal at the point of incidence. Sometimes to bluff you, what they will do, they will give you the complementary angle of that. So don't get carried away. Angle of reflection is similarly the angle made by the reflected ray with the normal at the point of incidence. Then comes laws of reflection. Now, while everything else is understood, this was what I was more interested. Imagine this like one small mirror, okay, or a plane. When we say incident ray, reflected ray, normal lie on the same plane, this is a plane. This plane can make many angles along with the reflective surface. So it's not possible that your incident ray is coming in this plane and the reflected ray will be in that plane. When we say that the incident ray, reflected ray, and the normal all lie on the same plane, means they are coplanar. And how do you understand best coplanar? Take 3 pens. If you are able to chipkaufa your textbook behind them, such that every pen is on the textbook, then they are called coplanar. 2 rays will always be coplanar. Between 2 rays, you can always make coplanar in any orientation. But once a third ray comes, you have the problem of like the happening of a tripod, of a camera tripod. Have you seen the 3 legs? They are not planar. Because if you have a planar tripod, it will fall. However, the Trishul of Lord Shiv, that is planar, coplanar. That same orientation is here. Fork. Have you understood? Incident ray, reflected ray. These are also very easy, nothing great. Next, from here starts your chapter, actually. Spherical mirrors. Plane mirrors we have studied in grade 8. This is, don't write plane mirror like plain dosa. It's plane mirror, P-L-A-N-E. Spherical mirrors terminology. A spherical mirror is always cut out from where? A sphere. So first imagine a glass sphere. So a glass, the center of curvature is like a football, okay? And the center of curvature will be right at the center of the football, which is inside the football. That sphere, from that sphere, you will be cutting out surfaces. So what you will get, although the shapes you see them like broken pieces of bangle, they are not broken pieces of bangle. They are like saucer plates. Have you understood? Or petri dishes that we use in biolab. So the center of curvature of a spherical sphere is the center of the hollow sphere of glass of which the mirror is a part. ठीक है? टकले का एक क्वेश्चन है. The center of curvature of a concave mirror. Now interesting, concave. All of you know the difference between concave and convex. Concave mirror is that mirror where a person can sit inside. He is inside the cave. And the inside surface is the polished surface. The outer surface is the rough surface. Make the person sit inside the cave. That is called a concave mirror. So if you see the concave mirror, where is the center of curvature? The center of curvature is always inside the mirror. Are you able to understand, or all of you, any doubt what I am speaking? If you take a concave mirror, ऐसा एक concave mirror हो गया ना, ऐसे figures आएंगे. So the center of curvature will be inside the mirror. But if you take a convex mirror, then the center of curvature is outside the mirror. In both cases, the center of curvature remains on the same side, but the polished side changes its orientation. Okay, radius of curvature of a spherical mirror is the radius of the hollow glass or the hollow sphere of glass of which the mirror is a part. Clear? Be very particular with this because such questions come in assertion and reasoning. So every word and every line has a meaning. Center of a spherical mirror is called its pole. So where can be the pole? Imagine the sphere was that like a football. The football is the sphere. Then the center is inside. The center of curvature is inside the football. Where is the pole? The pole will be on the scalp side of wherever you are taking out the mirror. The center of the mirror is called the pole. Are everyone clear with what is a pole? Anya madam, pole समझ में आया तो? Pole लेकिन center of curvature और pole के बीच का difference समझ में आया? Center of curvature is the center of that football. Pole is the center of the portion that you are snapping out. भाई समझ में आया तो? अब ये सब भूल जाओ सुप्रीम कोर्ट ऑर्डर. अभी ये कोर्ट में ध्यान दो, इसी में नंबर मिलेंगे, ठीक है? वरना दुनिया काटेगी आपको फिर, ठीक है? आइए इस डायग्राम को देखते हैं. So if you see this, I don't know how much of the gray portion you are able to see. This gray portion, if you see this gray portion, this is the radius of, this is what has been made as the rough surface. I need to check, huh? Lights, this is the convex surface, right? So this is the rough side and this is the concave side. This is the concave side. Man is made to sit inside it, so it's like a cave. And this is roughed on the inner side, so the outer side is actually your reflective surface. So this is concave surface and this is convex surface. Now if you see some definitions, although principal axis and all we will see later also, silver coatings have been done on this side, silver coating is there on the inner side. Okay, fine so far? Okay. Principal focus. These definitions again qualify for assertion and reasoning. Principal focus do not have one definition. Their definition changes for the type of mirror that you're using. So first let us look at the type of mirror. Now this is typically a concave mirror where the etching has been done on the pate mota side. So it's a concave mirror. Make the person sit inside. And remember, all the questions, numericals that we will get for mirror will be 99% on concave. But when we go to lens, the questions will be 99% on convex. ये याद रखना, क्योंकि कॉन्केव में ही तरह तरह के इमेजेस बनते हैं, कॉन्वेक्स में तरह तरह के इमेजेस नहीं बनते हैं. हाउ डू आई रिमेंबर सर? Every day your mom, dad or anyone who drives the car, the mirror on the windscreen is actually a convex mirror. So you don't see different type of cows every day or different type of goats. वही गोट ही दिखता है, बड़ा छोटा टेढ़ा बड़ा वैसा नहीं दिखता है. तो कॉन्वेक्स में there is no type of variation नहीं है, इसलिए उसका सवाल ज्यादा नहीं आता है. This question will come more. Shall we? So let's see what is the principal focus. The principal focus समझते कैसे हैं? Distant rays are always taken as parallel. These rays are taken parallel and parallel to the principal axis. What is principal axis? Imaginary line which joins this particular focus as well as the pole. So the best idea is once you have located the pole, make a tangent at the pole and make a perpendicular to the tangent. That's your principal axis, main rekha. Now, principal focus of a concave lens, the rays will go impinge upon the concave surface, and then concave mirror is also, sorry for using the word lens, concave mirror is also known as a convergent mirror, because it will converge all the rays at a common point, and that common point is known as the principal focus. Our next question comes, did these rays actually come and meet at the focus? Yes. So this focus will be known as a real focus. You need not memorize, keep your concept clear. So principal focus of a concave mirror is a point on the principal axis to which all the light rays which are parallel and close, another word you can use is coaxial, right, converge after getting reflected from the concave mirror. And since the focus is formed by actual intersection of rays, this focus will always be known as a real focus. And the distance of the focus from the pole is known as the focal length, which will always be half the radius of curvature. Remember that also. ठीक है? अजय उसको थैंक यू क्यों नहीं बोला रे? तेरे प्रॉब्लम को सॉल्व करके दिया वो? स्वार्थी इंसान खाली डाउट छोड़ता है, जब डाउट कोई सॉल्व करके भेजता है तो थैंक यू नहीं लिख सकता है. यही सीखा है क्या स्कूलों में? घर जाके मेरा मतलब हो गया ना, मेरा मतलब हो गया, और फिर इसको आके पूछता है सुप्रीम कोर्ट ने वो रूल अच्छा किया या नहीं किया. तुमको काटना चाहिए था. चलो समझ में आया? Concave mirror has a real focus and is in front of the mirror. In front of the mirror. In front always means with respect to the reflective surface. Because you have seen his message, that I know. So in English we have some beautiful words. Please, may I, thank you. तो वो thank you बोलिएगा. यही तो हम स्कूलों में सीखते हैं. Next, image of a sun can be produced by a concave mirror at its focus. So distant rays are the rays. ये देखो, ये दोनों से आप assertion reasoning के question बना सकते हैं. A sun's image was formed at a point by a concave mirror. That point was known as that point is being termed as the principal focus. Principal focus is defined. We will say this is true, and this is the correct explanation of this. समझ में आया तो? So image of a sun, and why? Sun is a distant object. Distant object से जो rays आते हैं वो हमेशा parallel होते हैं. ठीक है? Next, distance of the sun's image from the concave mirror gives an approximate value of the focal length of the mirror. Now this can be a competency based question. A concave mirror has been given to you. How do you find its focal length? What is your best estimate for the focal length? Take the concave mirror outside and try to focus it on the sun, and then you will find that there is a small dot which has been formed. The distance of that dot to your mirror is a rough analysis or rough estimate of the focal length of that mirror. Clear? बहुत अच्छा. Focal length is equal to radius of curvature by 2. Now, second point comes, what is the principal focus of a convex mirror? So for that, let's again see a convex mirror. Now, in a convex mirror, whenever the rays are coming, these rays will become divergent. Divergent rays will never meet. Divergent rays are like how I advise and how you do. बेटा घर जाके पढ़ना, मैं तो वीडियो गेम देखूंगा, तो दोनों divergent rays हो गए. तो डाइवर्जेंट रेस को क्या करना पड़ेगा? एक्स्ट्रापोलेट करके पीछे लाना पड़ेगा. सो व्हाट इज द प्रिंसिपल फोकस? नाउ द प्रिंसिपल फोकस इज अ पॉइंट ऑन द प्रिंसिपल एक्सिस फ्रॉम व्हिच रेज appear to diverge after getting reflected by the convex mirror. Since these rays are not meeting actual, so this focus will be a virtual focus, and this focus is behind the mirror. अब behind का मतलब समझो ना, behind is always with respect to the reflective surface. यहाँ भी focal length will be half of the radius of curvature. But when we go for problems, then we will see कोई एक focus आपका negative बन जाएगा, focal length कोई एक positive बनेगा. भाई यहाँ तक anyone has any doubt? No doubt, all okay, fine, right. चलिए, a convex mirror has a virtual focus and is situated behind the mirror. Focal length is always equal to radius of curvature by 2. Clear? So what all did we learn so far? What is a spherical mirror? What do we understand by pole of a mirror? There is one thing that CBSE does not touch, which is known as aperture of a mirror. कभी बोला तो जान लेना. Aperture is the portion in which the reflection is happening. The entire mirror may not be exposed. Have you understood? The entire mirror may not be exposed to light. only the portion of the reflective surface which is exposed is known as the aperture. मतलब मिरर को आपने कितना expose किया है, that's called the aperture. So we know now. Any doubts, just tell me. I'm going to say some terms, you just tell me. Center of curvature, is it clear? The radius of curvature, is it clear? How is the center of curvature with respect to each of the mirror? For a concave mirror it will be always inside the mirror, for a convex mirror it will be outside the mirror, क्योंकि center of curvature तो यही रहेगा, लेकिन ये mirror इस side है, इसलिए ये outside the mirror है. Radius of curvature you understand. Pole do you understand? Okay. Do you understand what is principal axis? Do you understand what is focal length? Okay. Do you also understand what is real focus and virtual focus? Do you understand what is principal focus? Very good. You understand what is focal length? Do you understand what is focal plane? What is focal plane? Yes. Can anyone tell me what is focal plane? You can इसमें ले लो, इसमें बोलो focal plane क्या है? ये ऐसा ये जंजी वाला मत बोलो. ये I'm gonna have something. कोल्ड कॉफी मे बी. ये क्या है? ये क्राइस्ट का क्रॉस बना रहे हो, सामुराई स्वॉर्ड चल रहा, अब फिर से हाथ हटा रहे हो. द परपेंडिकुलर, द प्लेन बोल रहा हूं. परपेंडिकुलर इज अ लाइन. डोंट गिव मी मोरॉनिक रिस्पॉन्सेस. परपेंडिकुलर इज अ लाइन, प्लेन इज अ सरफेस. सो इट्स कहां पे इंटरसेक्ट हो रहा है? यहां पे इंटरसेक्ट हो रहा है. यहां पे एक प्लाईवुड का प्लैंक ले लो. प्लाईवुड देखे हो ना पूरा, और उस प्लाईवुड को पूरा 90 डिग्री में प्रिंसिपल एक्सिस के साथ ऐसे गजब करके घुसा दो. That is known as the focal plane. Focal plane is the plane whose orientation is perpendicular to the principal axis. Have you understood? So if these rays are not parallel to the principal axis, they are parallel, but they are not parallel to principal axis. They are coming in this manner. Then where will they meet? They will still meet at one same point. It will not be the point on the principal axis, but will be a point on that same axis. Means it will be a point on the focal plane. Focal plane पे ही वो intersection होएगा. समझ में आया? ये part जो मैं समझाने की कोशिश की. Have you understood? आगे चले. चलिए. Next. An image is formed where at least two reflected rays intersect or appear to intersect. So either two rays will intersect directly or the two rays will be made to intersect. That's a crude word. So we will say they are always made to intersect when the rays are divergent. If they are convergent, obviously my view and your view converge together. So they will meet. And if they are divergent, they will not meet. So we have to go back and say, when we were in KG class, our views used to converge. So that is the point of convergence. वहां तक rays को ले जाना पड़ेगा और वहां पे image form होगा. वरना इमेज फॉर्म होने के लिए आपको दो रेस को तो मीट करवाना ही पड़ेगा. असलियत में मीट हुआ रियल इमेज, खींच के मीट करवाया तो वर्चुअल इमेज. समझ में आया? रियल इमेज कैन बी टेकन ऑन स्क्रीन, वर्चुअल इमेज कैन नॉट बी टेकन ऑन स्क्रीन. अब आपके मन में आएगा, सर मूवी थिएटर में जो इमेज है वो वर्चुअल है, पर वो स्क्रीन में कैसे जा रहा है? द फर्स्ट इमेज ऑफ द मूवी थिएटर इज द वर्चुअल इमेज. आफ्टर दैट देयर इज नेक्स्ट इमेज इज द रियल इमेज. तो मैग्निफिकेशन बनता है ना. ठीक है? यस. एक इमेज को एक बार और भी तो इमेज बनाया जा सकता है ना. फर्स्ट इमेज कैन बिकम एन ऑब्जेक्ट. टेलीस्कोप वगैरह में आप क्या करते हो? हाउ डज अ टेलीस्कोप वर्क? आप टेलीस्कोप में सबसे पहले क्या करेंगे? जुपिटर को सबसे पहले एक छोटा सा इमेज बनाएंगे, फिर एक लेंस यूज करेंगे ताकि वो जुपिटर उसके लिए इमेज बने, ऑब्जेक्ट बने. द फर्स्ट इमेज बिकम्स द ऑब्जेक्ट फॉर द नेक्स्ट लेंस और द मिरर दैट यू विल यूज. देन यू विल अगेन मैग्नीफाई इट. That image can be made real. That is what I'm saying. ठीक है? Rules. Now, how many of you remember the rules? Tell me the rules. Rules for concave. A ray of light which is parallel will always pass through the principal axis. वाह, एकदम जबरदस्त. Second, a ray of light which passes through the center of curvature goes undeflected. It goes back at the same. ठीक है? इसका बड़ा यूज है और इसका बड़ा यूज है इमेज बनाने के लिए, क्योंकि देखो ए करके नीचे आएगा और ये मौसी का बेटा भी यही नीचे जा रहा है, ये यहाँ पे इन दोनों का मिलन होने का बहुत चांस है. इधर में क्या है, इमेज बहुत अच्छा फॉर्म होता है. समझ में आया आपको? बहुत अच्छी बात है. तीसरा वाला रूल क्या है? रे ऑफ लाइट पासिंग थ्रू द फोकस. वो था जस्ट उल्टा, मामा एंड बुआ. ठीक है ना? will always become parallel to the principal axis. And the fourth one is the angle of incidence that you make at the pole is same as the angle of reflection that you make at the pole. Now, why this is happening out here? Because at this surface, if you draw a tangent, it's almost like a plane mirror. If you draw a tangent, Are these fine? Okay. Now the next, image formation. Now, although the book will discuss like this, for us what is to be very important is this one, don't forget. This is the only case of a concave mirror where you will get an erect, virtual and magnified. Magnified आगे भी मिलेगा, बियॉन्ड सी वाला भी मैग्निफाइड आएगा, लेकिन वो वर्चुअल नहीं होगा. तो हम इसको थोड़ा सा आराम से पढ़ते हैं. Concave will have all real images except one, that is this. Concave will have all inverted images except one, that is this. Concave will have magnified in two cases. One is here, one is that Beyoncé case. So this is very unique. हाँ, कौन सा?
Infinity से आगे focus में object रहता है, highly enlarged image.
That is when you are keeping at focus, then object is forming at infinity. He is correct. और infinity पे object नहीं रखते, object focus में रखते हैं.
हाँ, नहीं मतलब but image is highly enlarged.
हाँ, तो you are saying the object is at infinity. Object is at. So what I am saying, ये तीन ग्रहों का मिलन सिर्फ यहाँ पे आपको दिखेगा. This is the only case where you will find virtual image, you will find erect and you will find magnified. ठीक है, दोबारा विजिट करेंगे. और इस केस में आपको कहां रखना है? आपको अपना ऑब्जेक्ट रखना है बिटवीन दी पोल एंड द फोकस. सो इसको मैं हमेशा बोलता हूं डेंटिस्ट लिपस्टिक करके याद रखने का. वैनिटी मिरर्स क्वालिफाई फॉर दिस. ठीक है, दांत वो भी क्वालिफाई करता है. तीसरा, शेविंग मिरर्स आल्सो क्वालिफाई फॉर दिस. Even the mirrors that you have at the at the spec store, जहाँ पे आप चश्मा लगा के डेस्क पे देखते हो ना, so there also we use this type of mirrors, because you are not supposed to see, you're supposed to see this area big, so that you can see whether it's fitting your eyes properly or not. End of the day, remember this case. इसके बहुत सवाल आते हैं. Means when we try to solve problems, though we'll do a revision, in this case the magnification factor will come greater than 1, because magnification, and it will have a sign which will be positive. Why? Because it is erect. It is erect. पहले वर्चुअल में नहीं बोलेंगे, इरेक्ट है इसीलिए. ठीक है ना, आगे चलते हैं. Now these are the four things. Number one, now this is a classical example of what happens at a focal plane. Have you seen this? Here I am not showing the rays parallel to the principal axis. The rays are parallel, but they are not parallel to principal axis. In such a case also they will meet exactly not at focus but on the focal plane, anywhere on the focal plane. Clear? ये वाला कौन सा है बताओ? अच्छा, इसमें हमें इमेज साइज क्या मिलेगा बताओ? हाईली डिमिनिश्ड मिलेगा. डिमिनिश्ड ही वर्ड होता है, हाईली डिमिनिश्ड नहीं होता है. वेरी स्मॉल. डिमिनिश्ड इटसेल्फ मींस वेरी स्मॉल. ओके, सो द ऑब्जेक्ट्स आर एट वेरी फार अवे. This is the principle that is used, principle that is followed in any telescope. Every telescope will first have a mirror. That mirror will make one small image of Jupiter. आतिश बोलेगा सर इन्वर्टेड बना जुपिटर का. जुपिटर गोल है बिट्टू, उल्टा बने सीधा बने हमें कोई मतलब नहीं. रसगुल्ला रसगुल्ला ही है. कभी बोलते हैं क्या प्लेट में देने से छोटा या बड़ा बोलते हैं, उल्टा रसगुल्ला तो नहीं बोलते हैं. इसको फिर हम क्या करते हैं, मैग्नीफाइंग ग्लास से कॉन्वेक्स लेंस से बड़ा करके देखते हैं. ठीक है, व्हाट इज दिस केस? This is between C and F. If you do between C and F, the image will be formed always. No, this is beyond C, where the image will be formed between C and F. Beyond C and between C and F are just cousins. So if you have the image which is have the object beyond C, the image will be formed always between C and F. It will be a smaller. तो इसका मैग्निफिकेशन थोड़ा बात करें कैसा होगा. इसका मैग्निफिकेशन नेगेटिव होगा क्योंकि ये उल्टा है, and its magnification will always be, value will be less than 1 because there is no magnification happening. इसके केस में हमें मैग्निफिकेशन 1 मिलेगा, 1:1 same scale. However, the sign will be negative because the object is inverted. This is the case of center of curvature. The same thing we will see in convex lens at 2f when we form the image at 2f. Now ये इसका just उल्टा. Now you are having the object between center of curvature and focus. So your image will be formed beyond C and it will be an enlarged image. It will be an enlarged image. So if you go for magnification of this, the value will be negative and the magnitude will be more than 1. Any doubt anyone has in this part? समझ में आया? So when you get a numerical, don't start solving it just because हाँ v equal to इतना दिया, 1 by v 1 by u ऐसा नहीं. Before you start doing the numerical, just try to apply your analogy. मेरा आंसर कितने के बीच में होना चाहिए? If you know these 5 diagrams, then you should be able to predict where your answer should lie. And you yourself will say whether you are doing it correct or you are doing it wrong. Samjhing? Well, let's go to the next one. Next one is uses. This is NCERT, so don't worry. So uses are applications of concave mirror. Number one, head mirrors of doctors ENT to concentrate on light. So doctors have got a head mirror which is almost appears to be like that of a DVD or a compact disc, and there will be a light. The light will fall on the mirror and he will be able to focus that light into the ear canal of yours to actually see what is happening in your ear canal. Concave metal is used in dish antennas. So dish antennas are what? They are concave surfaces. So distant lights which are coming from the satellite are falling on the dish antenna and then they converge upon at a point where your receiver unit will be there. Okay? That means if you want to disturb your neighbor, just change his dish antenna's orientation. All he will say, the Tata Sky signal is not there. Please try calling your service operator. तुमने किया है वो. A light bulb placed at the focus of a concave mirror. Now this is a torch, the principle of a torch. Or old days, Rolls-Royce and Ambassador cars, where was the bulb placed? The bulb is always tried to be placed at where? At the focus. So if the bulb is at the focus, then the rays get reflected and they will try to travel straight. Yes or no? Okay. Then used by dentist shaving mirror. This is example 1. This is the case of virtual images, enlarged images, and erect images. Large concave mirrors are used for solar energy application to focus sun's rays on heating surfaces. Concave mirrors work as excellent reflectors where you want more concentration of solar rays. So we can use them also for solar heaters. Next, rules for obtaining images by a convex mirror. Now this is a very rare case problem that comes. There are 3 imaging rules, and the 3 imaging rules are: if a ray of light is coming parallel, it is diverged in such a way that it appears to diverge out from the focus. Have you understood? ये उल्टा है, लेकिन ये समझने में मतलब बनाने में प्रॉब्लम हो जाता है. Ray of light which is parallel to the principal axis is diverged in such a manner that it appears to diverge out from the focus. A ray of light which is directed at the focus, you can't reach the focus because it's a mirror, which is directed at the focus, becomes parallel to the principal axis. And the third one is a ray of light which is directed to the center of curvature will again reflect back on the same path. इस पे चौथा वाला वो एंगल वाला नहीं होता है. बात समझ में आया? All fine? Right. So image formed by a convex mirror. In convex mirror, we study 2 cases only. One case will be when the object is that one placed between pole and infinity, between pole and infinity, and the second one is the object at infinity. Let's try to see this one more, because this is the everyday case that we see in our car mirrors and all. Object can be anywhere between the pole and the infinity. When the object is between pole and infinity, what is the output you see? Whether if it is an elephant, you see an erect elephant, and the erect elephant is always smaller than your actual elephant. So the image will always be formed between P and F. Image cannot go beyond focus. Remember this. Image will always be virtual, erect, and smaller in size. Can you predict what should be the magnification value for here? The magnification value will be plus because it is erect. However, the magnitude will always be less than 1 because you are getting a smaller. और हमेशा सोचो, मेरे पीछे गाय जाता है, भैंस जाता है, अब मैं गाड़ी चला रहा हूँ, पीछे आतिश का रहा है, मेरे को तो चुट्टू सा आतिश के दिखेगा, उल्टा तो नहीं दिखेगा ना. पेपा पिग जैसा ऐसा करके हंसता है. तो स्मार्ट लग रहा है आज तो. चश्मा डालने के बाद ना चेहरे में निखार आ गया आपका, है ना? बस स्मार्ट लग रहा है ना. घर वाले भी यही बोल रहे हैं. इस बार राखी के दिन मतलब हाथों में क्या प्लास्टर बन के गए थे क्या बाहर? कोई राखी ना बांध दे मुझे इस बार. स्टड बन गया है लड़का. अकेले अकेले he doesn't go by the straight, he doesn't go by this way to the bus stand. Have you seen his route? He will always go in front of P Tower, ऐसा जाके सामने से परपेंडिकुलर मार के जाता है. कोई इंतजार करता है क्या वहां पे? मैं 2-3 दिन देखा ना आपको, वही रूट में जाते देखा, मेरे को डाउट हो गया. मतलब बहुत अच्छा. प्यारा बच्चा है. Object at infinity. So all objects at infinity, where will you expect the image to form? The image will be formed at F, and the image will be virtual, erect. Image can never be inverted in convex mirror. It will always be erect, and it will be highly diminished, which will be point size. We don't expect any ray diagram from here. However, we do expect some application based questions because the rear view mirror is a direct application of this type. Have you understood? Achha. When you go down to the basement, you do see some safety mirrors which are kept there. What type of mirrors are those? Spherical mirrors. Is it a concave or a convex?
Convex.
Convex, because they are all bulged outside. And put some gray matter. When I'm coming out with my car, if another car is coming out from a different angle, I should be able to see that as a small car, distorted but not ulta. Ulta nahi dikhna chahiye. So it's all always be a convex mirror. ठीक है? चलें आगे. Next, uses of convex mirrors. Convex mirrors are used as rear view mirrors, erect, diminish, and wide angle. Many children forget this thing. Wide angle view. A convex mirror gives you a wide angle view. You know what is wide angle view? Nowadays, televisions are said to be having almost like 180-degree view. That means even if I sit here, I should be able to see the television completely. So convex mirror में आप up to 120 view चला जाता है. 120 is a very, very big span. Then differentiating mirrors are also used as security without touching the mirror. If the image is of the same size, then it's a plane mirror. This is grade 8. Grade 8, do you remember the characteristics? Image distance equal to object distance, image height equal to object height, image is erect, virtual, and the image undergoes lateral inversion. That is, it is horizontally flipped. If you get an image which is smaller in size, then it is what? Convex mirror. And if you get the image which is magnified, then it is concave. Take a new spoon in your house, hold the spoon in front of your hand and turn both sides. One side is concave and one side is convex. Convex में हमें छोटा वाला आतिश दिखेगा और concave में हमें बड़ा वाला दिखेगा. Clear? Now, next, sign convention. Sign convention. Do you want me to use the whiteboard and explain once, or are you fine with this? Tell me if you want me to use the whiteboard. I'll use the whiteboard. Anyone wants me to use the whiteboard and explain the whole thing? Sign convention. First of all, think yourself like the Cartesian coordinate system, right? And place your mirror in such a way that the pole of your mirror is always on the origin. Then, sir, should the incident rays come from this side or that side? It always says incident rays always will come from left hand side to right hand side. Based on that, you orient your mirror. Understood? So if I am a concave mirror, look at me, I am the Cartesian coordinate. The concave mirror is now shaped in this side, right? So all the rays are going to come on this side and they're going to get reflected on this side. So if I am a concave mirror, then my distance to the focus will always be negative, not positive, negative. This is the negative side. And everything that happens, the object distance is always negative because object is placed in front of the mirror. Image distance, well, in the case of dentist and lipstick, the image is formed on this side. So the image distance will become positive. The object height is always positive because objects are always taken as Peppa standing tall on the ground. Image depends upon how the image will be. So if you are standing right up and you are facing to the positive side of the y-axis, that is taken as positive. And if you are standing down, then that is taken as negative. If you are making a ray diagram, always remember, if you are naming the image as A on the toe and B on the head, the object as A on the toe and B on the head, remember the same thing with a complement, that is A dash and B dash, or A dot, AC, BC, whatever you want to write. Maintain the same chronology. That only will show you that the image has been flipped. Understood? Then, so let's look at this particular mirror. This is a concave mirror. If you look at the concave mirror, then the concave mirror has its focus on this side. So the focal length will be negative. The radius of curvature will be negative. Then the object distance will be negative. The object height will be positive, except for one case of dentist and lipstick, where it will be positive image distance and a positive image height. All other images are going to make their head down. So they all will be negative image height and नेगेटिव इमेज डिस्टेंस। इससे ज्यादा इसमें कुछ है ही नहीं। जब आप प्रॉब्लम सॉल्व करेंगे, ओके, लेट मी गो टू द नेक्स्ट स्क्रीन। सो इट सेज, let's look at the sign convention. Okay, object is always placed on the left hand side of the mirror. Image distance v for a convex mirror, image distance v for a convex mirror is always positive, because in a convex mirror images will be always formed on the back side. Focal length of a concave mirror is always negative. Focal length of a convex mirror is always positive. Height of the object is always positive. Now, linear magnification. Magnification is what? It's a ratio. Magnification, here I will use, मेरे को थोड़ा यूज करना है, ठीक है, 1 minute। क्या एक्सप्लेन ले गया क्या? अच्छा, सॉरी। मैग्निफिकेशन, मैग्निफिकेशन मतलब मन मन में क्या, कोई बड़ा हुआ है, सिंपल सी बात। सो मैग्निफिकेशन विल ऑलवेज बी height of the image divided by height of the object. Have we understood this? This is magnification. Mirror है कि नहीं वो सब बाद में देखेंगे। Height of the image, it's a ratio of height of the image. Magnification is always expressed with two slots. One is the magnitude and one is the sign. The sign can either be plus or can be minus. If it is plus, it is erect. If it is minus, it is inverted. This magnitude can be greater than 1, less than 1, equal to 1. Equal to 1 का मतलब है सेम साइज, जिसे हम कहते हैं, आपने तो आर्चिस गैलरी नहीं देखा, हमारे टाइम पे लाइफ साइज पोस्टर्स बोलते थे हम, सेम साइज। Greater than less than 1 means this is smaller than object. In a sense, you can say diminished. Greater than 1 means magnified. This is larger than object. Larger than object. Have we understood this? Okay. And for a mirror, this is always negative of v upon u. Clear? इसमें छेड़छाड़ मत कीजिए, जस्ट इसमें वो नेगेटिव रखिएगा, और ये आपको समझ में आ जाएगा। ये सिमिलर ट्राइंगल से फॉर्म होता है, दो ट्राइंगल्स फॉर्म होते हैं, दोनों सिमिलर होते हैं, वहां से हम रेशियो ऑफ कॉरस्पॉन्डिंग साइज लेते हैं, तो ये नेगेटिव v अपॉन u होता है। इतना चीज समझ में आया? एंड देन आई ऑल्सो ऑलवेज से दैट देयर इज वन टेक्निक दैट आई ऑलवेज यूज, क्योंकि हम यूज कर रहे हैं मिरर। मिरर में होता है आई बोले बंदर का भाई, तो एडिशन में भी होता है आई, इसीलिए मिरर में हमेशा एडिशन होगा। और एडिशन कैसे होता है वो भी याद रखिए। वीआईपी से आता है v, ये पहले 1/v, सबसे पहले वीआईपी, इंडिया में वीआईपी कल्चर है, प्लस 1/u इज इक्वल टू 1/f। अब आप भूल नहीं सकते हैं, कैसे याद रखना है? मिरर में i और एडिशन में i, तो मिरर में हमेशा एडिशन होता है। और अगर हम लेंस में जाएंगे, लेंस में होता है e और निगेटिव में भी होता है e, और फॉर्मूला वही रहेगा, पहले वीआईपी कल्चर, फिर 1/u 1/f। When you are solving problems, whatever data is given to you, you adjust that data based on the orientation of sign convention. Whatever is asked to you, वो ऑटोमेटिक अपना साइन लेके ही निकलेगा। इट विल कम आउट विथ इट्स साइन। यू डोंट ट्राई टू डू उस्तादी टू अलॉट साइन टू एन अननोन थिंग। हैव यू अंडरस्टूड? से somebody says find the image distance. Now you don't put your head, oh, this is convex mirror, its image should come on the right hand side, no, I will take v as positive, no, this is concave, I will take v as negative. No, you are only supposed to say let the image distance be v. That's it. Once you solve the problem, the v will come out with its sign, वो अपना साइन लेके आएगा। समझ में आया? Any question on this part, children, in these two things? If you have any doubt, the same thing we will repeat in lenses also. Remember, when you are going for magnification, in the case of mirror, we have a v negative out here. This negative will not be there when we will be studying for lenses, right? However, it is always hi upon ho. Correct? And the magnification will always have a sign and a magnification value, which is the magnitude. The sign tells us whether the object is erect or inverted, and the magnitude will tell you that whether the object is enlarged, a same size, or a size lesser than that of the object. Is that clear? Right. Can we go back then? Excellent. Intelligent children. Okay. So mirror formula is 1 upon V plus 1 upon U. So you have understood how to use the mirror formula. I don't think we don't have any slides after this. That's the end of the slide. So we'll break a little bit early today. Any questions so far? Next class that we will take up will be all questions based on questions that have come in the examination in the recent past. Right? And let's discuss also, when is our next class? Our next class is tomorrow. And tomorrow we start with triangles. Right? Tomorrow, we start with areas related to circle. Sorry, we will start with areas related to circle. So tomorrow will be a Gyan class. Maybe we may not be able to tackle problems. So we'll take a complete Gyan on all type of scenarios. And then we will take 1 to 2 classes maximum, 1 to 2 classes. And our next class, which is scheduled for Tuesday, is now not happening. We will be meeting next on Thursday. And on all likelihood, we will be having a physical class out here. Should there be any change to that, I will let you know. Means class will be there. Whether the class will happen online or offline is the question that needs to be answered.